Bright Tuty. Every student matters.
Welcome students to this session. Let us start learning with a very important topic that is called distance time graph. Now when I say about distance and time, we know that this graph can give us the information about how much distance must be covered in how much time. Now, before we move to understanding how do we make a distance time graph, we need to understand how many or how varied can be the graphs form. So let us take about a very common example which we see in the newspapers or magazine to present various commodities or their runs. So if you have seen the IPL series, you must know in given hour how many runs are scored can be very well represented by a graph. Now what is a graph, students? A graph is a pictorial representation. That means a picture form of what? Of data. So which kind of data we are referring at? We are referring to the data which is interlinked. So when we are talking about a cricket match, we know we have to see how many runs are scored in per hour. So what we do, we can draw it by a bar graph. Looking at the bar graph, it becomes very easy to read the data. For example, in the first hour, only 1 run was scored. In the second hour, there were 5 runs scored. In the third, there were 3. In the fourth, there were as max as 10 runs. In fifth hour, again 2 runs. And in sixth, there were 6 runs scored. So by the bar graph, we can run or read the data in a very easy form. Now it is very interesting to know that the graphs cannot be only of one type. There are various types of graph. One such is bar graph, which we have just seen. Another kind of graphical representation is a pie chart. Now what is a pie chart? The pie chart, you get to see that in a graph you can mention which portion. Let's say we show the whole of the world atmosphere by 360 degree of my circular pie chart. So out of that 360, we know that around 71% is my nitrogen, around 22% is my oxygen. Actually, it is 78%, right? And the remaining 1%, it is 1. Okay. So from a pie chart, what we can read? Let's say the 360 of the pie chart, that is the angle at the center, shows me the whole of the atmosphere we have. And we know that nitrogen occupies the maximum, that is 78% of the total atmosphere. So it is the biggest portion on my pie chart. Oxygen, being the second, has 21% of share, and other gases are only 1%, including carbon dioxide, SO2, NO2, etc. So when we look at the pie chart, we are again using a mode of graph, a pictorial representation to show the data. Now graphs are not just sustained to bar graph or pie charts. There are important categories which we go as the line graphs. Now when we talk about the distance time graph, it will be a perfect example to have a line graph. Now students, how we can draw a line graph? Let us look at the situation here. Here we are given a line graph with a very common thing where the weight of the man and the age is being compared. So let's say on the x-axis, that is the graph which is shown on the x is given by the age in years, and the y-axis is showing me the weight in kg. So the man, when was 2 years in age, was around 10 kgs of weight. Then around 4, it became 12 or 40. Then around 6, it became 18. As you go up and up and up, you can see for any age what was the weight of the person. So at around 16, the weight of the person was around 48 kgs. So how does a line graph also helps us? It gives us the relationship between the two axes, that is the y and the x-axis. Now if I know that at what age what was the weight of the person, I can compare it during the total span of his life. So you can see at 18 he has grown the weight from 47 to 70. That means the maximum growth given here. So this is how we get to know or read the data from a graph. Now we are going to draw the graph for our distance and time. So people, if we have to draw for distance and time, we need to understand that which axis we need to choose for distance and which axis we have to choose for time. So people, let us start learning about the distance time graph. Okay, now we will take a graph sheet. Now what is a graph sheet? It is a green paper you see in the back of your laboratory files, or even sometimes you see that you can buy this as an extra stationery from the stationery shop. So on a green paper, what you see, the graph sheet is made so that there are vertical and horizontal lines. All these vertical and horizontal lines are for my use. So what we need to do, the very first thing is draw my two perpendicular axes. When I draw the two perpendicular axes, the perpendicular vertical shows me y and the horizontal shows me x. What you need to do? Number one, to make a graph, you need to first draw two lines perpendicular to each other on it. So as you have seen in this diagram, x and y axis are the two perpendicular lines. Then you will mark the horizontal axis x, o, x dash. So people, let us understand what we are doing. We are asked to make two perpendicular lines on our graph and mark it as x, o, x dash, and the perpendicular one as y, o, y dash. So these are my two axes that I am going to get. So what we call these two axes as x-axis and y-axis, and the point of intersection of xo, x dash and yo, y dash is what we call as the origin. So that is my point where everything I start saying, it begins from this point. Now the two quantities which we have to draw graph between, this is my third point. So the first point was draw the two perpendicular lines. Second point is mark them as xox and y dash, and the point of their intersection is called my origin. Now the point number 3 here is that we are going to look that which two quantities are going to go on my two axes. So the two quantities between which the graph is drawn must be shown on the x and the y axes. So this is very important to understand. You can mark any two quantities which are related to each other on the x and the y axis. We show the positive values on the x axis on the ox. So if I redraw my graph, the two perpendicular lines, my x, o, x dash, this side it is positive, on this side it is negative, this is y, o, y dash, this side it is positive, and this side it is negative. Okay, now positive values on the y-axis are shown along OY, and positive values on the x-axis are shown along the OX. Now in this chapter, we are considering only positive value. So we can even forget about drawing the graph with all these three axes. We can only draw the graph with two perpendiculars, that is YO and YOX, right? So we are not considering any negative values. Hence, we are going to take only this part of the graph which is going to be useful to us. So we shall be only using the shaded part, right? Now, Buju and Paheli found out that the distance traveled by a car and the time taken by it to cover the distance, we can plot the data of this on the graph. So where is the table we are having? There is a table which Buju and Paheli got for a motion of a car which is moving in 0 minute, 1 minute, 2 minute, 3 minute, 4 minute, 5, 8 is covering 0 kilometer, 1 kilometer, 2, 3, 4, 5 respectively. So this is the data we have for the motion of a car. Let's start putting this on the graph. Can we make a graph of this? Definitely we can. We have to just follow the following step. Number one step is what? Draw the two perpendicular lines to represent the two axes and mark the OX and OY. Now you know we are not considering the negative side. So we are going to draw two perpendicular lines, and this is my OX, this is my OY. Okay. Now we have to decide which quantity we are going to put on the x-axis and which on the y-axis. Now people, just to give you a convention, when we draw or when we make the graphs, we always put on the y-axis which is changing with respect to the x1. So what we have to actually consider? We have to consider that whether my distance is being covered in the given time or not. The time is anyway going to go forward, but my distance will decide whether the motion is occurring or not. So people, in this case, we are taking the x-axis as the time and the y-axis as the distance. Okay. Once this is done, we go to the next step, that is the third step. We have to choose a scale. Now, why choosing a scale is important? Now, if you go back to the data, you see that the time covered is 1 minute, 2 minutes, 3 minutes, 4 minutes. So, a scale with 0, 1, 2, 3, 4 interval will be better. If I take a scale of 0 to 10, then all these values will come in between only my first box, which is not right. On the other hand, the distance again is covered as 0, 1, 2, 3, 4. So again, I'll not take a distance to be 0 to 5 or 0 to 10 in one go. I'll take the scale as if I can take the values or data in an elaborate manner on my graph. So choosing a scale to represent the distance and another to represent the time is your next step. For the motion of the car here, what we have, 1 minute is given to be 1 centimeter. Now on the graph sheet, students, if we go back, your graph sheets are drawn as such that each of this box, this little box you can see, is equivalent to 1 centimeter of distance. So what we have defined on x-axis, the 1 minute, 1 centimeter shows me 1 minute, and on my y-axis, I am again choosing 1 centimeter box, that is this box is given to be as 1 kilometer. Now students, it is important to understand we are taking time on the x-axis and on the y-axis the distance, right? The distance is covered. Let's go and understand forward what is other things that we need to know for making the graph of the distance and the time for the motion of the car. So let's see here. We have taken the distance on the x-axis to be 1 centimeter given as 1 kilometer, 1 minute, and the distance to be 1 kilometer on the y-axis will be given as 1 centimeter. Now we need to mark the values that are given in the data, the table. So we need to see at what time, what was the respective distance covered in my motion of the car according to the scale. So for the motion of the car, you know that 1 minute, 2 minute, 3 minute, all are marked on the x-axis from the origin. Similarly, on the y-axis, 1 kilometer, 2 kilometer, and so on are marked on the y-axis. Now we will mark the points of the data. So the data, if I remember, my motion of the car in time 0, 1, 2, 3, 4, 5 minutes is given to be covered in the distance in kilometer as 0, 1, 2, 3, 4 and 5. So let's see here. We have to mark the points on the graph paper to represent the set of values for the distance and the time. Now the observation recorded should be according to the table we have shown. So let us see about 0 minute, the distance moved was also 0. So corresponding point on the graph will be what? It will be 0, 0 for my first point, right? The second point will be when the time was 1. We see that the distance traveled will also be 1, and hence we get the second point to be here on 1 and 1. So on reading your graph, students. So let me read this out. The points corresponding to the set values on the graph will be shown with the origin for 0, 0. For 1 minute, the car has moved 1 kilometer. Hence, the point was 1 and 1. To mark the set of values to locate, we need to represent 1 minute on the x-axis and 1 kilometer on the y-axis. Hence, we can see that 1 kilometer on the y-axis and 1 minute on the x-axis. When we draw two perpendicular lines, they meet at this point. And hence, this point becomes my point of the second point, the second data point. Now, once we get this, we can start drawing a line to the corresponding values. Let's do it for 2 and 2. So in 2 minutes, students, we know 2 minutes on x-axis is here. It is covered 2 kilometers, that is on y-axis is here. What you need to do? You need to draw perpendiculars from this line, and here you get your third point. Okay, people? So on, if you keep on putting your data points, you will see 3 and 3 will lie on the point, on the graph where my 3 and 3 will coincide. So this is how we gonna draw the distance time graph. So you will be seeing that on making the graph, when you join all these lines together from 0 to 1 to the line to 1 to 2, we are going to make a straight line like this. So this straight line which we are getting is showing me the set of points of the graph that are corresponding to the position of the car at the various time. So students, what we get to see, that on a single graph we can plot all the points, and the line that shows me, the single line that was getting me all the points on it from 3, 3, 4, 4, 5, 5. I see that the bus is, or the car is moving in a straight line with a uniform speed. Now, how we can say that? Because on joining all the points on the graph, it is a straight line. This is the distance time graph for the motion of the car, and whenever you get a straight line on a distance time graph, your car is executing motion which is of which kind? Uniform. So it is uniform motion. The car is not executing any non-uniform motion. That means that the car, if the distance time graph is a straight line, it indicates that the object is moving with a constant speed. Now, however, if the speed of the object keeps changing, the graph can still be there, but it will be of some other shape. So this is the graph for the uniform velocity or speed. So students, do you remember about Bojo and Paheli doing an experiment where they were traveling by a bus and they were noting at every half hour what was the distance covered by the bus? So this is what you can actually do for making the graph, such as for the bus, when the time was noting from 8 to 8:30 to 9 to 9:30 to 10, the distance traveled by the bus was initially in 15 minutes 10 kilometers, but in 30 minutes 20 kilometers. In the next 30 minutes, it was again 20 kilometers, that is 40. So what we can do, we can know the time interval and we can know how much distance is covered, and hence such a graph can be plotted for any kind of motion, may it be the motion of the car or may it be the motion of the bus. So here what we understood, that a distance time graph, as any other graph, we have to understand that what we do when we make a graph. So people, my distance time graph, if I have to start writing, number one condition we need to understand is what is the use of the graph. So a graph is used to represent data. Now to represent the data which we have, we can represent it in the pictorial form. Now for the pictorial form, we generally make two axes. One is the OX and one is the OY, which meet on the O, which is the origin. Now we decide which is my x-axis and which is my y-axis. Once that is done, for my distance time graph, we take the y as the distance and the x as the time. Once this is done, the next step is to mark a scale, and lastly, when you even mark the scale, you get to mark the data points on it. Finally, you will join all the data points to see where is your graph looking at. If it is a straight line like this, what does it shows? It shows a uniform motion, right? It shows that the speed is uniform or the motion is uniform. That is, the bus is covering equal distance in equal time, which you can see here, that in every 30 minutes there was a distance covered of 20 kilometers. So this is what we understand from the distance time graph. Now students, it is important to understand that the choice of the scale is not as simple as in this given example. You can choose your scale as you wish, but you should choose your two different scales to represent the desired quantities on x and the y axis. To understand, let us have an example. Let us consider that the motion of the bus that took Haley and her friends to the picnic. You remember, every 30 minutes, 20 kilometers covered. The distance covered by the time taken and the time taken by the bus are shown in the table 13.5. The total distance covered by the bus was 80 kilometer. If we decide that the 80 kilometer is the total distance and we want to choose the scale for 1 kilometer 1 centimeter, then what will happen? You have to have a graph of the length of 80 centimeter on the y-axis, which is not possible on the sheet of the paper. So what we have to do, we have to reduce the scale. So what we did, we took a scale of 10 kilometers showed by 1 centimeter. That will only take us the length of 8 centimeters on the graph, which is feasible. So the graph, the scale, the choice of the scale has to be very wisely done. This scale should be conveniently drawn. Now, if we show about the graph may cover only a small part of the graph paper, some of the points to be kept in mind while choosing the most suitable scale are, what is it? The difference between the highest and the lowest value of each quantity should be same. So what you are taking as a scale, your scale should be like this, that on the whole of the graph, the distance or the difference between the highest and the lowest value should be equal for the each value. The intermediate values of each quantity show so that the scale chosen is convenient to mark. So students, if we are taking this kind of a graph, we know that the graph is like 8 to 830. This means at point A, it is 815, which is readable. But if I take this as 8 and 815, this will become 8.7 minutes, which is not that convenient to read. Same, if I go with the scale of 10 to 20 ki jagah 10 to 15, then anything which is lying 20 to show 20, it will be somewhere in between like this, which is again inconvenient. Thus, we always choose a scale which is convenient to read for the reader or the observer, right? Now, to utilize the maximum part of the paper, we generally use the graph drawn and the scale to be divided, such as maximum of the x and the y-axis can be used. Now, suppose you are given a graph of 25 into 25 centimeter size sheet. One of the scale which meets the above condition can accommodate the data, right? That is, if we take 5 kilometer to be 1 centimeter, this will be the most ideal. Why? Because if I have 25 into 25, or if my 5 kilometers are 1 centimeter, to show 80 kilometers, I will be using what? 80 kilometer divided by 5 will be around giving me, it will be giving me 1 and 16 centimeters, which is very easily accessible in the 25 centimeter graph. Similarly, if I show 6 minutes by 1 centimeter, then again, to show the time between 8 to 10, that is 2 hours, it becomes easy or not. Let's see this. Can you draw the distance time graph of the motion of the bus? If we draw the graph by this, what we see? The distance time graph provide a variety of information about the motion. When compared to the data presented by the table, we see that the information about the distance moved by the bus only at some definite time intervals. But we can even tell more. On the other hand, from the distance time graph, we can find the distance moved by the bus at any instant of time. Now, this is something very, 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 very interesting, students. If you have a distance time graph, let's see, we go back to the distance time graph as we have seen here. What we can tell from the distance time graph is not just the data which we are plotting. We can even tell what is intermediate of them. For example, here, as you can see that 8:15, the distance traveled was 10. Let's say what was the distance traveled at 9:45 a.m. The distance traveled will be given by the perpendicular drawn on the x and the y axis. It is around 70 kilometers. we can tell the type of motion, we can tell the intermediate of the motion, we can tell a lot from a given graph. So students, just to look at this, what we are talking about. The distance time graph provides a variety of information to us about the motion when we compare it to the data presented in the table. For example, the data was giving me the distance moved by the bus only at the definite time intervals. But on the other hand, the distance time graph, we can find the distance moved by the bus at any instant of time, and thus we can tell more about motion. Suppose we want to know the how much distance was covered at 8:15. As I already told you, 8:15 on x-axis gives me the y-axis value to be 10 kilometers, and hence we get to see that what is the distance traveled, even intermediate of the time which was not in the data. We mark the point T on the graph which is perpendicular to the line intersected, and we get to know that T will give me the y-axis value. The distance corresponding to this value was given to be how much? It was given to be 10 kilometers, right students? From the graphs we have seen that 8:15 the distance traveled was 10 kilometers. What about the distance traveled at 9:45? We have just did it. We saw that it was around 70 kilometers at 9:45. Now the very important thing, students, can you also find the speed of the bus from the distance time graph? That is the question. I'm going to leave it, because the answer to this is yes. But this is going to come in your syllabus in your future classes. So you need to hold your horses till then and understand that yes, apart from just plotting the data and reading the data, we can tell the intermediate data, and as well we will be able to find the speed by the distance time graph. Here we come to the end of this. We will be doing some questions of the same chapter. I hope you understood and enjoyed this chapter. Thank you.